to talk about Maglev Train. I'm Quizizz.
I'm Xiaoying. I'm Wen. I'm Xuan. I'm Shuet.
So let's start now. So before we start explaining about Maglev Train, let me explain briefly about the Faraday's law and Lenz law. Faraday's law states that when there's a change in magnetic flux, an electromotive force is induced. Also, it states that the magnitude of the electromotive force induced is directly proportional to the rate of change in magnetic flux. So, when the rate of change in magnetic flux increases, the magnitude of the electromotive force will increase too. As for the Lenz law, it helps us to understand how electromagnetic circuit is related to Newton's third law and the conservation of energy. The law states that an induced electromotive force always gives a rise of a current whose magnetic field opposes the original magnetic flux.
This is one of the examples that is related to Faraday's law and Lenz law. When the north pole of the magnet goes into the coil, current is induced and magnetic field is created to oppose the magnetic field of the magnet. Therefore, at the end of the coil will be north pole. Same goes to the other way. When the north pole of the magnet goes out of the coil, current is induced too, and the magnetic field is created to oppose the magnetic field of the magnet. The only difference here with the first one will be at the end will be the south pole, as when this motion is repeated in a faster rate, the magnetic of the current will be larger.
So, what is Maglev Train? And why is it called Maglev Train? The word maglev actually derives from the word magnetic levitation, which is also the basis mechanism of this type of train. Compared to other normal train, Maglev Train uses electromagnetism instead of using electric motor. How does Maglev Train works? It's easy. It uses the concept of attractive force and repulsive force between two types of magnetic poles. Currently, there are two types of Maglev Train: electromagnetic suspension. Another one is electrodynamic suspension. As years go by, more and more countries uses Maglev Train instead of normal train, such as Germany, Japan, and China. Why is it good to use Maglev Train then? Hey, my friend is discussing about this. Why don't we take a look? Let's go!
Did you know the advantage of maglev?
Not really.
Actually, the main advantage of maglev is maintenance, because there is no contact between the train and the gateway, so the moving part is lesser. Okay?
Yeah.
Then the second advantage of maglev is maglev move in a high speed, because there is no friction between the train and the gateway, so the noise produced is limited.
Oh, what about the disadvantage of Maglev Train?
The disadvantage, I think, is the high cost due to the cooling system of the Maglev train.
Oh,
Get it?
yeah, I got it.
Electromagnetic suspension is used on the German train system. It is arranged on a series of C-shaped arms with the upper arm attached to the vehicle and the lower inside edge contain the magnet. The guideway is located in between the upper and lower edge. The stator is made from ferromagnet and the support magnet is made from electromagnet.
So how does it levitate? It is levitated by the attractive magnetic force between the electromagnetic coils on the train and the ferromagnetic rails on the train guideway. So have you wondered why ferromagnetics is chosen? Ferromagnetics is chosen because it is easily magnetized with induced current or made into permanent magnet. As the force of attraction between the magnet increase with decreased distance, the system is unstable. How can we overcome this? So the current is needed to control with care to maintain the desired suspension height. The function of feedback loop is constantly changing the strength of magnetic field produced by the electromagnet. The feedback loop and onboard electronic system is used to measure the gap between the electromagnetic coils on the train and the magnets on the guideway to keep in control. The feedback circuit is used to control the electromagnet to keep suspended object in the right position. Gap sensors will control the strength of electromagnets on the train. The power failure of track's propulsion system will require the usage of onboard backup batteries to temporarily power the train's levitation system. Overall, electromagnet is used to stabilize the train.
Before I talk about the propulsion system of the electromagnetic suspension train, I'll be showing you the video of the Shanghai Maglev Train, which is the fastest commercialized train in the world, currently traveling at its fastest speed, which is 430 km per hour. The propulsion system of EMS uses the linear synchronous motor. Linear synchronous motor is basically like a normal rotating motor, just that the stator is being cut open and laid out flat so that it can produce a linear motion. So what lets it move in a linear motion? The stator, which is shown here in the ferromagnetic rail, has alternating current in it, which runs using the three-phase current. Three-phase currents are basically varying currents that have different speed in them, as in their currents are supplied at different times. So by using the right-hand grip rule, you know that currents flowing in different direction will give different magnetic poles.
Besides the current in the guideway being supplied by three-phase current, the rotor of the train, which has its magnetic poles aligned in an alternating way, will also experience a change in the polarity of the magnetized coil due to another alternating current. This causes the magnetic field in front of the train, which is located in stator of the ferromagnetic rail, to pull the train, while magnetic field behind the train adds more forward thrust due to repulsion. This helps the train to move forward. Therefore, they will have to be timed properly so that the train will be propelled forward.
How does it start speeding up from the constant speed? Its speed is actually proportional to the frequency of the changing in the magnetic poles. So let's say if you want it to go faster, you just have to speed up the change in magnetic poles, which is controlled by the currents, and it will be able to accelerate. To break it, you can use the opposing magnetic field, to break it, you can use the opposing magnetic pole, so that once there's this end and end there, it will create a resistance and the train will be forced to slow down and followed by stop. What if emergency happens? If emergency happens, they have air flaps just like those normal airplanes to slow them down, or they have extra wheels that will give them emergency brakes.
For the EDS to start moving, it uses the concept of like poles repel and unlike poles attract between the magnet. However, it required the train to have wheels in order to accelerate to the takeoff speed required for the levitation force to become strong enough to lift the train.
Right here, I'm talking about EDS levitation. What is EDS levitation? That is shown in this diagram. You can see they have a pair of magnets at the both sides of the guideway, and they have North Pole and South Pole at the both sides of the train. You can see over here, they have a North Pole at the left hand side of the train, and South Pole at the outside of the gateway, and North Pole at the bottom of the gateway. This will cause the North Pole and North Pole repel each other and lift the train up. This South Pole will help the North Pole because the South Pole will attract with North Pole and lift the train up also. You can see over here, there's almost the same system here, but there's the opposite pole in both sides. Then the train will lift above the gateway about 10 cm.
Levitation is achieved by taking advantage of Lenz's law and Faraday's law. A changing magnetic field will occur when the magnet in the body are passing by, generating an electromotive force in the electromagnetic circuit in the tracks. It simply means that if the train passes by the electromagnets in the track quickly enough, the resulting change in magnetic field will induce a current within the electromagnets. The induced current will then have an opposing magnetic force, causing the magnets in track and train to repel against each other, and thus allowing the train to levitate and maintain its position within the width of the track. Now that we know how the levitation works, what about propulsion? Propulsion is the action of driving the train forward. So, how is it possible? In EDS, there are two rows of guideway which is made of electromagnets. On the right side of the guideway, it has alternating polarity north, south, and accordingly, where on its left side of the guideway is just the opposite poles of the right side. You can see here on the side of the train, there are many magnets with opposite polarity aligned and opposite polarity to the guideway. These magnets are actually superconducting magnets which made of superconducting wire. So, why is the magnet arranged like this? It's because the unlike poles attract and make the train forward, where the like poles repel and causes the train forward as well. This means that the motor of an EDS train is the interaction between the superconducting magnet and the electromagnet. Now, try imagine what will happen if the train moves forward. So, this is what happens after the train moves forward. The magnet on the side moves forward as well. Without changing the polarity of the superconducting magnet and the electromagnet, the train will be moving backward now, as the attraction happens here and the repulsion happens here. Same goes to the another side of the guideway. Now, to prevent this, the poles at the guideway will change due to AC current, where the poles on the side of the train will remain the same. Therefore, the train will continue to move forward in a very high speed.
For EMS train systems, the electromagnetic structures are wrapped around and under either side of the guideway. This acts as the undercarriage. The train is constantly levitated off the guideway even when it is stationary. As for the EDS system, it employs an undercarriage-like landing gear for aircraft. For lift-off and landing, the vehicle begins to levitate at the speeds in excess of 40 km per hour and achieves full levitation at around 100 km per hour. This means that the vehicle would require wheels to let it start moving before it can fully levitate itself. This may be of advantage in case of power failure.
After that, you can see in the EMS, the magnet attract up toward the laminate iron ray in the guideway and lift the train up. Due to the attractive force to lift the train and reduce the friction between the train and the guideway.
The distance between the electromagnets and the guideway in electromagnetic suspension is around 10 mm. It must be monitored and adjusted by the computer system to prevent the train from hitting the guideway. Hence, this system is quite unstable and might fail without consistent monitor. However, electrodynamic suspension is much stable and does not require constant lookout on the system. The distance between the train and the guideway is around 10 cm. So, why EMS only require 10 mm while EDS is 10 cm? This is because if the gap is too huge for EMS, it will be too difficult for it to control the magnetism and attraction to the guideway.
For your additional knowledge, scientists is also planning to use this magnetic levitation concept in the future use. As we know, flying car will be one of the goals in the future as expected. It claims to be able to eliminate congestion while reducing the carbon dioxide emission and the dependence to the foreign oil. Magnetic levitation also contributes on the biological research. The magnet in the petri dish is able to lift the cell from the bottom of the petri dish. Compared to the regular petri dish that the cell is grown, the Maglev cancer cell can produce a more similar structure and produce more similar protein to a tumor in a living animal. This is able to help the researchers to develop a better cancer treatment, and also this invention may also use in producing realistic organ in a lab one day. NASA has been developing a new launching aid by using the magnetic levitation system to propel the spaceship. This Maglev launching aid is able to save the design and launching costs while providing a safer launching method. So, this is the end of the video. Hope you all like it.